So on this next one, I want to find the equation, and I have an initial condition and my slope. So, of course, this is dy over dx. And if I want to get back to my original equation, I'll have to integrate it. So I'm going to have to move a couple of things. Dx have to go to the opposite side, and 2y will have to go over here, but he'll now be in the denominator. So it's going to be dy over 2y and 1 over 3x dx. Hope that's not too confusing about where I'm putting things. And then I'm going to integrate. So I could pull the 1/2 out, and then I'd have 1 over y dy. And I could pull the 1/3 out, and then I'll have 1 over x dx. So when I integrate, I get 1/2 natural log of absolute value of y and 1/3 natural log absolute value of x, and we'll put the c over here. I only need it on one side. It's easiest to keep it on the x side just to be consistent. And so if I would like to try and get y by itself on this one, I notice that I have these coefficients that, of course, I can put back up. So I'll have natural log of y to the 1/2 and natural log of x to the 1/3. And then, in order to get the natural logs to disappear, gonna need a superhero. So of course on the left, I just get the square root of y, or y to the 1/2. And on the right, I can split it. So I have x to the 1/3, and remember it's times e to the c, but e to the c is just a constant, which is going to fit nice and neatly in there as a c. And so now I have square root of y equals c, and then I'm going to have times cube root of x, or x to the 1/3. And then my last step to get y by itself is I would have to square. So I have y equals, now remember, everything here is getting squared, but if I square a constant, it's still a constant, and then this will be x to the 2/3. So now that I've solved for y, I can plug in my point. So I'm plugging in 2 for the y value and 8 for the x value. And 8 to the 2/3 would be 4, which will make c be 1/2. So that original equation is y equals 1/2 x to the 2/3. Just a little bit of work.